remember what we talked about in the last video. We talked about Fundamental Theorem of Calculus, which gave us this relationship. So we know that if a function is defined with this integral from a number to x, variable x, then the derivative of that function is equal to the integrand here. So it's equal to the original function. So we can rewrite this as, if I call this function g of x, I can rewrite this expression as derivative of g of x is going to equal to f of x. But this means that the antiderivative of f of x is g of x, right? Remember from section 4.9 when we talked about antiderivatives. So due to the result of Fundamental Theorem of Calculus, part 1, we're going to use this notation, integral of a function is going to equal to an antiderivative of f of x. And we're going to call this an indefinite integral. Okay, so just be careful, there is no upper or lower limits here. So it's just the integral of f of x. So the result here is going to equal to a general antiderivative. So it's going to equal to a family of functions. So let us look at this example. The indefinite integral of secant squared is going to equal to the antiderivative of secant squared. So we're trying to figure out a function whose derivative is secant squared. We know that tangent's derivative is secant squared. So this is just going to equal to tangent x plus, maybe there's a constant c. Let us compare this indefinite and definite integral to see the difference clearly. So when we look at the indefinite integral of 2x, that's going to equal to just x squared plus a constant. So this is a family of functions. Versus if we look at the definite integral of 2x from 0 to 5, we know by Fundamental Theorem of Calculus that's going to equal to x squared divided from 0 to 5. Right? So that's just going to be 25 minus 0. Oops. 25 minus 0. This is going to equal to 25. So this is equal to a number versus this is equal to a family of functions. From section 4.9, we remember the antiderivative of a lot of different functions. So in here, with this notation, we can write down the antiderivative of all these functions with the indefinite integral notation. So integral of a constant will be kx plus c. Integral of e to the x will be just e to the x plus c. So forth and so on. So we have done all of these in section 4.9. So here, maybe a little note would be to look at this first row. Just like in the definite integrals, with indefinite integrals, we can take the constant out and we can divide the indefinite integral of sum of two functions into two indefinite integrals. Let us look at this example. So we want to find the integral of this difference of two functions. But remember from the first row, if we have a constant in front of the function, or if we have a difference or a summation, we can actually use these rules. So here I'm going to divide this into two indefinite integrals. So we can write this as 10 times integral of x to the 4. And then I'm going to take the integral of 2 times secant squared. But again, we can take 2 outside, and I can say minus 2 integral of secant squared. So we know the antiderivative of x to the 4 is going to be x to the 5th over 5, and the antiderivative of secant squared is going to be tangent x. So we can write this as 10 times x to the 5 over 5 minus 2 times tangent x. And then since there might be constants, we can just combine the two constants for both of these indefinite integrals and just write it as a single constant. Let us look at another example. So here we have a quotient, and we don't know how to find an antiderivative of this quotient as it is, but we can simplify this to be able to find an antiderivative easily. So if I simplify here, if I simplify 2t squared over t squared is going to be 2. T squared, square root of t over t squared is going to be just square root of t. And then 1 over t squared is going to be just t to the negative 2. Now, if you compare these two, we were not able to find antiderivative here, but we can figure it out here easily. So the antiderivative of 2 is going to be, so I'm going to do this again one by one, right? So you're going to do antiderivative of 2, antiderivative of square root of t, antiderivative of t to the negative 2. So I'm not going to write integrals over and over again. I'm just going to skip that step and just write the answer. So for 2, I need 2t. For square root of t, remember this is t to the 1/2. So I can take the antiderivative as just t to the 3/2 over 3/2. And then for t to the negative 2, increase the power by 1, you get t to the negative 1 over negative 1, or I can just write it here. And do not forget the constant, like I just did here. Don't forget your constant. Whenever you're dealing with indefinite integrals, you want your answer to be a family of functions with a constant.